Here's a physics example. h of t equals negative 4.9 t squared plus v sub 0 t plus h sub 0. You'll also hear that someone say v naught plus h naught. H here represents the height in meters above the ground after t seconds. We're assuming no air resistance. V sub 0 is the initial velocity in meters per second. H sub 0 is the initial height in meters. Note there's another formula book when the problem uses feet. Alright, Vicky, who's standing on the second floor of the D building, which is 5 meters high, throws a balloon with an upward velocity of 10 meters per second at Eric, who is standing on the ground. At the moment the balloon was at its highest point, Eric turned and saw it. Should be a comma. How much time had elapsed? How many seconds did he have to move from the time the balloon was thrown? So let's start plugging this information in. We have h of t equals negative 4.9 t squared. What is v naught? That's our initial velocity, 10 meters per second, so we'll plug in 10 in for there. T plus our initial height, which would be 5. Now I'm going to make this simpler in terms of doing it. We're not going to take into account the height of the people. So now, what are we looking for? At the moment the balloon was at its highest point, Eric turned and saw it. How much time had elapsed? So we're looking for time, a t value, at the moment it's at its highest point. What is that point called? That's the vertex. So what we want to do is find the vertex of this equation. How do we go about doing that? Well, you can't use that formula that's in the book. So how have we done it? You can find the quote-unquote x-intercepts, or the t-intercepts in this case, which would be a good thing, especially for the latter part of the problem. You could say, I can find, remember we're looking at a parabola here, and the vertex x value, or in this case the t value of the vertex, is always at the midpoint of any two points at the same height. So whether or not it's these two or these two, whatever it is, the t value of the vertex is always going to be at the midpoint of it. So we can just find 2 points that have the same, at the same basically y number. The easiest one to do is when it is the y-intercept, because then that number goes away and we're going to be left with a common factor of t. So we'll say let h equal 5. So 5 equals negative 4.9 t squared plus 10t plus 5. We'll get a 0. Now we can factor out a t. Set each one equal to 0. So we get 4.9t equals 10, or t equals 10 divided by 4.9. Now we have a fraction with a decimal in it. Let's get rid of that decimal. We'll multiply the top and bottom by 10 and get 100 over 49. So what that's saying is that the initial time, let's say it was thrown right here, the initial time was 0. And then in order to get to that same height as it was thrown up, it's coming back down, it will be at 100 over 49 seconds. Now how do I find the t value of the vertex here? It's going to be at the midpoint of it. So we'll have 0 plus 100 over 49 divided by 2, or in other words, 1/2 of this 100 over 49, which would be 50 over 49. So how much time had elapsed? 50 over 49 seconds. Now it says how many seconds did he have to move from the time the balloon was thrown? What is that asking for? We're going to make it a little simpler in order to do this part and say, so that we'll look at it again. The ball's thrown here. We don't need that axis. It's actually here. The ball's thrown up higher, and we're gonna assume it's when it hits that ground there. So what is the height when it hits the ground? It is 0. So 0 equals negative 4.9 t squared plus 10t plus 5. Now, how do you go about solving that? Let me move this over so you can see it. Doesn't look like it's a nice thing to factor, so let's use the quadratic formula. Remember, always put the variable that we're solving for. T equals negative b, so negative 10 plus or minus the square root of 100 minus 4 times 4.9 times 5. All over, actually that's negative 4.9, all over 2 times negative 4.9. So negative 10 plus or minus, this would be, if you want to take out your calculator, that's okay. You would have 4 times 5 is 20. And just think 20 times, we'll take the 0 part, would be times 49 would be the same as 2 times, or 4.19 would be the same as 2 times 49. So that would be 98. So we'd have the square root of 198. All divided by negative 9.8. Now that's not going to be a nice number. Take out your calculator and just type it in. So we'll have negative 10 plus the square root of 198 divided by negative 9.8. So that gives us a negative 0.42 approximately. And then if we do that again, type it in again and change this to a minus, we get 2.46. Now, when we look at that and you see these 2 times, what does this negative 0.42 mean? That means if this were extended back here, that would have occurred at negative 0.42. Now that doesn't have any meaning on the problem. So he has 2.46 seconds to move. Now that's it for the problem. Let me show you another way we could have done the first part. How else can we find the vertex? We have completed the square. That one's not going to be quite as nice, and I'll throw that one on the back of it. We have h equals negative 4.9 t squared plus 10t plus 5. So I'm just going to give an alternate way to go about finding the vertex here. We're going to factor out the negative 4.9. So we'll have t squared minus 10 over 4.9 t, and then we'll leave the 5 alone. If we take, again, I'd probably make this in order just to make the numbers a little bit simpler, and I don't know if it will make it so nice. Get rid of the decimal, or we could leave it there. It's not a big deal either way. We'll have negative 10 over 4.9, which will be negative 5 over 4.9. And then we're going to square that to get 25 over, what would 4.9 squared? You could do that one. It can be done using 5 minus 0.1, but just as easy right now, we'll just use this. So we'll plug it in. Now what number did we really add in? We added in negative 4.9 times 25 over 24.01. So this will be a negative number, and we have to add the opposite of it. And that will end up being 4.9 times 25 over 24.01. Now what is this going to reduce to? Remember, 24.01 is just 4.9 squared. So when that reduces, it will have 4.9. So we get negative 4.9 times t minus 5 over 4.9 squared. And then we have to get a common denominator for that, so we'll need 5 times 4.9, and then add that to the 25. So we'll have 49.5 over 4.9. And this tells us that t equals 5 over 4.9, which is the same thing as 50 over 49 seconds, is the vertex time. And that's it.